So I built a programming language from scratch. It's called Mtlang. It's a compiled statically typed language written in C++ that generates LLVMIR and produces native binaries. Let me show you everything. So let's start off with MTC tech version. We see a version string, and MTC is actually on yay. So if you're on Arch, you can just do yay, or even paru. You can just do yay s MTC, and you can install the latest version from GitHub. Source will be in the description as always. So let's create a little test, shall we? Just to show, let's do test.mtc. Let me hold on. Test.mtc. Let's just do print hello world, and then we can just do mtc test.mtc test, and we can do /test, and we'll see hello world. That is pretty easy. That's basic. Anyone can do that. That's fine. Let's write this a bit more complicated. So we have a lot of different things in this language. It's supposed to be a mix between C and Python. It's kind of the mix of them. It's like if they had a baby, do you know what I'm saying? It's like the simplicity of Python, no semicolons. You can do for I in list, etc. But we have the braces of C, and we also have the low level control that you can have in C with my standard library that I wrote. So let's do some variables. Int x equals 42. Let's say float pi equals 3.14. We can do string name equals mtlang. We can do balls alive equals true, and we can just print name. And yeah, we can run this. If we compile, we see it compiles, it works. Now let's talk about functions. So with functions, we have a very similar definition to C. So we have int a, int b, and we have defaults as well. So we can do b equals 10, and then we can do return a plus b. And then if we want to run add, we can just do, let's print string add. Let's just do 1, okay? Because b is already a default, we don't need to specify that. And it gives us 11, as expected. Now let's talk about classes. So class player, we just do it like that. Very, very C++. But here's where my classes are different. And I actually really like how these classes work. It provides a very object oriented like feel, and it's very easy to use. So we just specify a function. So if you don't know what the return type of a function is, you can just use func. It's kind of like it's kind of like auto in C. Just kind of figures it out as it goes along. So func string name, we can do set this dot name equals to name. So this runs when the class is instantiated. So if we do player equals new player, then in the brackets we pass in whatever the arguments are to new. So let's say we pass in a health as well. In health, then we have to set this dot health equal to health. And then we can literally just do, what's the name? Misty, the health, 100. And then we can print player dot health. Just have to string this because it is an integer. Yep. Compile that, run it, we see 100. Very simple. Now, let's talk about collections. So dynamic, we have dynamic and static arrays. So dynamic is basically Python's arrays. So let's just write a dynamic array equals, say, 1, 2, 3. We can then do nums.append. See, that only works with dynamic arrays. So we can do nums.append let's say 6. And then we can print nums.length. We'll probably have to string this, to be fair. See if that compiles. It does. And we see 4 because we have 1, 2, 3, and we appended the 6, so now we have 4. I think we can also print nums directly. And we see 1, 2, 3, 6. Perfect. So then we can talk about dicts as well, dictionaries. So we do dict string int scores equals, you know, the basic Alice 100, I don't know, Bob 85. And then we can do print scores Alice. Then we'll just have to string this. And we see 100 because Alice got 100. Perfect. Now, we can do control flow. So let's do 4. This is what I was talking about. Let me include one of my standard libs. So let's do from iter use range. And then we can do 4 I in range 5. We can just do print string of I. And we get 0, 1, 2, 3, 4. Perfect. Now we can do try blocks as well. So let's do try, throw, new, exception. So exceptions are classes, very similar to how Python does it. Let's just say something broke. Something broke. And then we can catch exception error. We can do print caught plus error. And that doesn't like it, but we see it works, okay? It caught the error. We don't really need to know what the error is as long as it got caught, you know what I'm saying? It's fine. So let's look inside the compiler, shall we? So ls source. We see we have these functions, these files, sorry. Let me just show these in NeoVim. Let's start from the top. Let's start from tokenizer.cpp. It's about 300 lines if I'm not wrong. Yeah, about 300. So let's just walk through this simply. I'm not going to bore you. We just have an array of keywords, array of single char symbols, etc. And yeah, we then just define some functions. So the tokenizer is a class that's defined in tokenizer.hpp. And then that's the tokenizer, pretty simple. Then we look at the parser. This is where it starts to get a bit more complicated. This is 1.3 thousand lines of code. And we basically just write a pretty simple parser. It's handwritten recursive descent with precedence climbing for expressions. No parser generators. It builds on the AST from the tokens. It builds an AST from the tokens. So let's look at the node types we have. So AST nodes. We have parameters, field declarations, method declarations. So, you know, stuff you'd expect from a compiler. And then let's look at the semantic analyzer. So this is the semantic analyzer. It basically checks the AST for something that doesn't really make sense. So if you try and do a string plus an integer, I mean, it's valid syntax, but you can't add a number to a word. Do you know what I'm saying? So this will throw an error here if that's wrong. So now let's look at the actual code gen. This is a very big file. Very big. 5.8 thousand lines of code. And it basically converts the AST into, you know, LLVM-IR. And then in the compiler, we basically take that IR. Actually, let's show you what the IR looks like. Let's do mtc test.mtc tac emit IR. And then let's just do test. As you can see, this is the IR, the intermediate language. So this is quite a lot of code, but you know, it works. So let's just look at the compiler. This is basically just the CLI utility. So this is what gets run when you run MTC. So yeah, it's actually pretty simple, to be fair, but it works pretty well. And then let's look at the standard lib. So we have exceptions. This is where all the exceptions are from. Class exception, value error, type error, null pointer error, runtime error, index error. Then we have IO. So we have a class called file, and you can do things like read, write, append, read lines. Then we have a bool file exists. We have iteration, so we have range, string contains, array contains, string array, reverse array, pretty simple stuff. We have math, min, max, sum, average mean, round in, floor in, ceiling in, absolute in, absolute float, square root, power, clamp float. Basically, all of these just use the libc. So we have libc wrappers for a lot of things. So my standard lib basically just wraps libc to you know, make an easier interface for developers. Then we have OS. So we have like os.run, os.env, etc, etc. Then we have random. We have reflect. We have strings. And yeah, we have a pretty fairly big standard library. And then let's just run the tests, make tests, make tests. As you can see, this is compiling and running each file in here, and that was a test that that test there failed on purpose. It was a test to check if the compiler could determine non-dynamic arrays between between dynamic arrays and non-dynamic arrays. So yeah, it's all working. It's all good. So yeah, thank you for watching, guys. I hope you enjoyed. The source is in the description. Install command is in the description. Feel free to like and subscribe. Thanks so much. In a bit, man.